Argentina. It is the source of the Rio Atul and has dimensions of 19 miles by 28 miles. Cero Escorial is a volcano. Best volume estimate is 58.6 cubic miles, located outside of the Atul caldera. Volcan overall, best volume is 21 cubic miles. And Las Lagunas Complex, also located within the caldera. Holocene activity may have formed the cinder cones on the northeastern side of the caldera. After the 2010 Mall eruption, the caldera was one of the volcanic centers that underwent subsidence along the secondary earthquake activity. Now, I don't think it was 2010. I think it was a different dating, and it was messed up on there. 2010. Yeah, it could have been because it's 2015. Huh. Okay, you guys, sorry. We don't have any views on this. Oh, we do. Hang on. We're going to go over here because I'm seeing quite a few on here. So we'll go over this way. Down here, we should be able to get a view of this area. All right, so we can look back in here. Oops, except for the persons. We look back over in this area. You can see this is a caldera area. Wow, that's neat. Sorry, guys, they cut the pictures up there, so. And moving on. Our next one is Casa Colorada. Casa Colorada is a dacitic volcanic dome complex. It erupted 17 million years ago. It has a volume of 1.5 cubic kilometers or 0.36 cubic miles. The complex formed in 3 stages involving a tuff ring, lava domes, and dacitic lava flows. It is constructed on red beds and a basement of Ordovician age. The main dome is dated 17.3 million years ago by potassium argon dating. The main minerals are biotite, hornblende, feldspar, and quartz. Oxide minerals are also present. And a view on this one, and we'll be moving on. We're going to Cerro Archibarca. And this is the Catamarca province. This is a volcano in the Andes. It covers a surface area of 20 square kilometers or 7.7 square miles. Lava flows descend from the conical edifice. So we can see us here. And we're still going to look to see. Sometimes we get views in this area, sometimes we don't get them. And none here. And we're moving on to Surabaya. Surabaya is a complex volcano in the northern part border between Argentina and Chile. It consists of 4 overlapping stratovolcanoes along a north-south line. The main volcano Foss is located on the Argentina side. Thought the summit of the complex is just west of the border. Though the summit of the complex is just west of the border in Chile. The volcano is about 800,000 years old, but it is associated with ongoing ground uplift, encompassing also more northerly Lastaria and Cordon de Azufru volcanoes. The 17,720 foot high summit is the source of 2 viscous dacitic lava flows with prominent levees that travel to the north. So we can see this is several of the cones that are down in here. And I'm going to try to see what it looks like, maybe. And the view, and we'll be moving on. Our next one is Robido. Volcan Robido is here and here. So this is the Caldera. This is a caldera in the Andes of Catamarca province of Argentina. Part of the central volcanic Sorry, you guys, I'm still getting over this whooping cough. Part of the central volcanic zone of the Andes. It is a volcano collapse structure located at an altitude of 15,320 feet in a depression. The caldera is associated with a less well-defined caldera to the south and several lava domes. The caldera has been active for the last 8 million years, and eruptions have created several ignimbrites. A recent eruption occurred 73,000 years ago and formed the Campo de la Pedra Pomes ignimbrite layer, about 2,300 plus or minus 160 BCE. Cerro Blanco formed the most recent caldera, as well as thick ignimbrite layers. About 110 cubic kilometers, or 26 cubic miles, of rhyolite were erupted then. The volcano is dormant since then, with some deformation and geothermal activity. A major future eruption would put local communities to the south at risk. The volcano is also known for giant ripple marks that have formed on its ignimbrite fields. Persistent wind action on the ground has shifted gravel and sand, forming wave-like structures. These ripple marks have heights up to 1 meter, or 3 feet 3 inches, and are separated by distances up to 30 meters, or 98 feet. Unlike dunes, they do not migrate with the wind and are stationary. These ripple marks are among the most extreme on Earth and have been compared to Martian ripple marks by geologists. And that's really cool. So we're going to look and see if we have any views here. We may. Or may not. Let me back up further. We don't. Oh, we do over here. So we're going to come right over here. We have one here as well. That's the one. But we're going to come over here to this one. So we can see the ripple marks that are on here. Wow, this is like cool. You see the rippling over here is what they were talking about. Nature is awesome. This is what it looks like down here. Now you can see the rippling they're talking about. This is all part of Robido. And moving on to the next one, Cerro Batici. This is a volcanic field in Argentina. It is located east of Central Volcanic Zone, away from the volcanic arc, within the Altiplano Puno Volcanic Complex, close to Zapalleri Volcano. The field is formed by 7 scoria cones and lava flows of andesitic, basaltic, andesite composition. The field was formed by volcanism contemporaneous with the ignimbrite volcanism of APVC, with Cerro Galan and La Pacana calderas being located nearby. Cerro Batici is part of a number of mafic volcanic centers associated with the Altiplano Puno Volcanic Complex. The 2 major calderas, La Pacana and Cerro Galan, are close to Cerro Batici. The eastern margin of Gacha's oldest caldera is located just east of Batici. Ordovician marine sequence form the tectonic basement of the area, but most of it is covered by ignimbrites and lavas between 8.5 and 4 million years old. The volcanic field covers a surface area 200 square kilometers, which is 77 square miles, including lava flows and scoria cones. The highest scoria cone has a height of 120 meters or 390 feet. The magmas that form the field have compositions indicating they derive from a primitive mantle magmas, which form in shallow mantle. So let's see if we have any views here in this area at all. This is a lagoon. We may or may not. I'm going to back out further. And we don't appear to on this one. And we'll be moving on to the next one, which is Cerro de los Chinchillas. You can see the horseshoe shape here. This is a monogenetic volcano in Chubut Province, Argentina. It is considered to be of Holocene age. The volcano developed on a basement formed of Mesoproterozoic and Neoproterozoic rocks and more recent volcanic and granite formations. So this is interesting, and then we're going to go over here. See if there's a view here. I noticed there is back this way. I don't know if there is down this way. Let me back out some more. We can come here. So we'll go right here. And it is right over this way. So we can look this way over here. It's back that way. And you guys, this is Argentina. And moving on to the next one, Cerro El Condor. And this is a stratovolcano in Argentina, and nothing else written about it, so it's the only piece of information I have. And we'll see if we have a road view. Oops. We have no views on this one, so we'll be moving on to the next one. Cero Escorial. I want to do one thing. Give you a little bit of a view of what this looks like. Okay. This is a stratovolcano at the border of Argentina and Chile. It is part of the Corrida de Gori volcanic group and its youngest member. A well-preserved 1 kilometer wide, 0.6 mile crater forms at its summit. Lava flows are found on the Chilean and smaller ones on the Argentinian side. The former reaching as far as 3.3 to 4 kilometers, 1.9 to 2.5 miles from the volcano. A sulfur mine lies 4 kilometers or 2.5 miles southwest of Escorial. Mining ceased about 1983. So this is, you can see where the crater is here. And I'm curious. Neighborhoods. And moving on to the next one, Cerro Morado. This is a monogenic volcanic field. It is part of a group of mafic volcanic centers in the Altiplano Puna region, which is dominated by silicic rocks such as dacite and rhyolic rocks. The field was formed during eruptions 6.4 million years ago, which probably lasted from half a year to several years. These eruptions formed scoria cones and a plateau of lava flows. And it's not good resolution here. And moving on to the next one, Cero Escorial. Cerro Escorial is a late Miocene era caldera in the Santa Cruz department of Bolivia and the Jujuy province of Argentina. It is part of the Altiplano Puna Volcanic Complex of the Central Volcanic Zone in the Andes. 50 volcanoes active in recent times are found in the Central Volcanic Zone, and several major caldera complexes are situated in the area. The caldera is located in a logistically difficult area of the Andes. We can see the caldera. You can also see a cone here. Looks like a cone down in here. Maybe it's not. And moving on to the next one, Cerro Redondo. This is situated over the Odovorcian basement east of the Sierra de Renicanda. The lava domes were erupted along a ring fractures on a preceding fault deposit containing blocks of breccia. It is a lava dome complex in the northern Puna, north of Rincon. Another report indicates just one isolated distinct dome. Intense hydrothermal alteration has occurred on the lavas. And this is a lagoon over here. I don't know if we have any views on the lagoon. I'm going to back out a little bit because I noticed that there is Laguna de Pozuelo over here. And there is one view over here. So let's go over here and see what we're going to see over here. And there's two over there. So we're going to turn. Wow, interesting. In our area, those are sheep. Okay. So our area would be back in that area. And I'm going to move up this way. I saw something. Hang on. Right here. I'm going to go right here. And then there's another one right there. This is a town area. Oh, buildings. We're in a town. We can see what we're looking at and back out that way. Interesting. Okay. We got all turned around here. I think we went to this one already. Yeah, we did. Okay, moving on to the next one. Cerros Negros de Llama. Okay, this is a monogenetic volcanic group in the Andes, Jujuy province of Argentina. The group is formed by about 4 well-preserved scoria cones between 330 to 490 feet high and 1,480 to 2,620 feet wide at the base. Subcircular to elliptic, with lava fields and one isolated lava field constructed on the Ordovician marine sediments and dacic lavas from the adjacent Cerro de Archibarca, 7.2 million years old. These cones are aligned submeridionally with the fault system in the ground. The lavas and associated dikes have porphyritic appearance and variable morphology. The lavas show no evidence of ponding in crustal magma chambers, suggesting that the large volatile content of the magma was sufficient to quickly transport it through the crust. Magma temperatures have been estimated at higher than 1,000 Celsius or 1,830 degrees Fahrenheit. The cones are constructed by reddish lapilli and lava bombs up to 1 meter or 3 feet 3 inches wide, with subordinate amounts of ash-like material concentrated in the talus deposits that have been formed by erosion at the bases of the cones. Arenite of sedimentary origin and dacite are found as xenoliths. The cones were presumably built by the Strombolian activity with occasional Hawaiian episodes. 2 other lava fields are also present. 2 lava flows of Cerro El Chileno
extended 2 kilometers or 1.2 miles southeastward, and are associated with pyroclastic mounds. That's 6 feet 7 inches or 3 feet 3 inches, suggesting some explosive activity but no cone. The cone may be buried beneath the lava or might have been eroded away. 3.15 kilometers or 1.96 miles north of Cerro El Chileno lies an isolated lava flow with circular shape. That's 750 feet by 720 feet that may be linked to a cone 1.2 miles north. The volcanic field is located in the Puna Altiplano Highland, a region with strong tectonic and volcanic activity since the Oligocene. Changes in subduction style of the Nazca Plate have produced changes in the nature and amount of volcanic activity, with the latest change being a westward shift of volcanic activity to the main belt of the Central Volcanic Zone. In the region, mafic volcanism has been active since the Oligocene. Most volcanism in the area is of silicic nature. And I notice we have a road over here, so I want to see if we have a view over here. And we do not. It would have been nice if we did, but we don't. So moving on to the next one, which is Cerro Galan. Went too high, sorry you guys. And it's pronounced Cero Escorial on the map. This is a dormant stratovolcano. Tuzco is a prominent volcano of the back arc of the Andes, part of the Central Volcanic Zone of the Andes. It is 17,999 feet high above sea level and was constructed during different stages over a caldera and lava domes. Some major lava flows emanate from the summit crater, and one confirmed and one possible flank collapse unit, as well as an ignimbrite sheet, are associated with this volcano. The first volcanic activity at Tuzco occurred 650,000 years ago and formed the Tuzco ignimbrite. Subsequently, lava domes were erupted and 3 lava flow units were named San Antonio, Azufre, and Tuzco. The latest lava flows are dated at 17.5 and 1.5 million years ago, and volcanic activity may have continued into the Holocene. Several thermal springs are associated with the volcano, and some have been investigated for possible geothermal energy production. Sulfur was formerly mined on the mountain. Argentina's National Route 40 runs along the foot of the volcano. So let's see if we got a view here. Because we've got National Route runs over here. We do have a view. Awesome. Oh, we can go up here. Let's go up here. So this is one of the flows from the volcano. We can look up here, and here is Tuzco. Okay, now we're going to go get a road view. Oh no, this red dot is over here. Okay, we're going to go get a road view. We'll go back out here. There we go. There's Tuzco. I would have thought it would be a clearer view, but that's Tuzco. Let's take a look around.
It looks like it's a rainy day there. Thank you, Google, for the awesome pictures. Okay, now we'll go down a little further. I think I want to go down a little further than where we were to see if I can get a better view. The only better view is maybe over here. We'll go over here. Awesome. Okay, now we'll do a zoom in. This is Tuzco. This is where the flows went down. Check out those big rocks. This is awesome. Okay, guys. You can come in and look at these on Google Earth. You can download the place marks and look at them for yourself. Some of these are really interesting, and there's a lot more to discover. Okay, now we're going to Cerro Volcanico. This is a cinder cone in Argentina located southeast of the massive stratovolcano of Tronador. The cone produced a single andesite lava flow, which has been bracketed in age between 7,000 and 14,000 years ago. And this is Cerro Volcanico here. And we're going to go and do a view. There should be some views down here, so we'll go over in this area here. You can see Hotel Tronador there. So we're going to look back this way. And you can see the volcano over here. I'm not sure what they're looking at over that way. There's another one here. The ones we're looking at are over here. And moving on to the next one, we're going to Champa. Champa is a volcano in Argentina close to the border between Jujuy province and Salta province. The volcano is of Miocene age. Champa has two summits. The 15,932 foot high Cerro Champa and the 4,796 meters or 15,735 high Cerro Galan. The volcanic edifice was constructed in two stages, the first consisting of explosive and the second of effusive activity. The explosive activity generated ignimbrites and pyroclastic flows. On top of these, many poorly preserved lava flows were emplaced in a radial pattern and constitute three separate formations. So we can see the three there. One, two, and three. And let's see if we have any views over here. Our only views are over in this area. I'm wondering what this is. We'll go peek. Wow, interesting. It's like salt beds. Yep, it's Salinas Grande. It's a park. And moving on to the next one, which is Chinchillas. And this is a lava dome complex in the northern Puna of the Andes in the Sierra de Recanada. The complex is constructed on an Ordovician basement called Achoite Formation. And we're going to get a view here. As I noticed, there is a road through here. But I don't see a view. Let's back up a little bit more. Oh, we got one over here. We'll go over this way. Just have to remember to turn around and look the other way. A dog. Okay, so we're going to look back this way. And our area that we're looking at is back there, but I'm not sure we're going to see very much. But this is all one area. And moving on to the next one. That was Minyuk we were looking at. Okay, so Chinchillas is here, and Munyuk goes here. We landed over here, so we're looking at Munyuk. Okay, our next one is Shivanar. Volcano, Shivanar. And this is a 16,814 foot high late Miocene volcano in northwest Argentina. The volcano is situated at the point where the main volcanic arc intersects the Coloma, Alacapato, El Toro lineament, a fault zone that has formed over 15 million years. A number of volcanic structures, including lava domes, stratovolcanoes, and monogenic scoria cones. This fault system has imparted the Shivanar center an extensional characteristic. So let's do this. We can get a look here at the cones. And in the area. And let's see if we can get a view here. What we have is a road over here, so we might be able to. Oh wait, we can go right here next to Rincon, and we can look that way. Oh, there was one over there too. I missed one. We'll still look at both sides. Okay. So if we look, here's the ones we're looking at over here. And we have butter. So we're going to go back up. We're going to go on the other side of Shivanar because I saw one right over here. Right there. Closer. Perfect. Okay, right here. So now we got to turn around. And we're looking here. awesomeness. And moving on to the next one. Conchiquito Volcanic Group. Conchiquito Volcanic Group. We can see one here. This is a small volcanic group of volcanoes north of the town of Buta Ranquil in Argentina. The main peak is Volcan Conchiquito, a stratovolcano of estimated Pleistocene-Holocene age. There are 8 satellite cones in the volcanic field, including Volcan Salanegra, which is a pyroclastic cone complex, and Volcan Ranquil del Sur, a small stratovolcano. And we're going to try to get a view here. I think we'll go right over in here. So I don't see anything closer. So we can look out this way, and here's one of the cones. This is the cone we were just looking at. There's another one right over in there. You can see one here. You can see one over in there. The one we were looking at is here. Oops. And moving on to Copihu. Copihu is a stratovolcano in the Andes on the border of Biobío region, Chile, and Nagun province. There are 9 volcanic craters along 2-kilometer line, the easternmost of which is historically the most active and contains 300-meter or 1,000-foot wide crater lake with a pH rating between 0.18 and 0.30. Eruptions from this crater lake have ejected pyroclastic rocks and chilled liquid sulfur fragments. Although the lake emptied during the 2000 eruption, it later returned to its previous levels. Copihu means sulfur waters in Mapuche. And we're going to see if we have any views here for this one. We have one over here. I don't see any up in that way. So we'll go over, I guess we'll go over here. So we can look over there and this way. I don't know what that is. Okay, you guys. So anyway, this is the areas out here. It looks like a ski lift. So it's a ski area. We'll go over in here. You can see where it says Copihu. So this is for this volcano. This is a town of the same name. Interesting. And moving on to the next one, which is Caranzuli. This is a back arc caldera in the Andes related to the Antiplano Puna Volcanic Complex. It formed along the Lopez geological lineament about 6.6 million years ago. Volcanic ash samples found on the coastal Cordillera of Chile may come from this volcano. The Ashita Stratovolcano is located close to the caldera. So the Caranzuli is here. I don't know if y'all can see this. So it's a back arc caldera. So we're going to see if we can get a view. So notice there is a road area through here. We may not be able to. So let's back up. We have one here, so we'll go right there. Okay, so this is the back arc caldera. Check this out. This is interesting. Wow. Okay, guys, moving on to the next one, which is Corrida de Cori. Corrida de Cori is a range of Pliocene to Pliocene. It is located in the Salta province of Argentina. Cero Escorial is part of this range. Cerro Negro, which is 18,304 foot tall, and Cerro Corrida de Cori, which is 17,700 foot tall, are other summits in the area. Lasteria may also be linked. Some glacial activity in the area has degraded volcanic landforms, but very little erosion is evident. It forms a volcanic chain with Luliliaco that extends towards Antofalla and Galan. This lineament is known as Archibarca lineament. Cerro Corrida de Cori and Cerro Negro are associated with the intersections between this lineament and east-northeast lineaments. Fault zones on the area have controlled the magma ascent, probably facilitating the eruption of fairly primitive basaltic lavas. Activity commenced in the Miocene with basaltic andesites and dacic ignimbrites and ended in the late Quaternary with basaltic andesites and former cinder cones. Very interesting. And no views for this one. And we're moving on to Crater Basalt Volcanic Field. This is really interesting looking. This is a volcanic field in Argentina in the Chubut province. The field covers a surface area of 270 square miles and a width of 60 kilometers. Major cones in the field are Cerro Contreras, Cerro Firmen, Cerro Negro, Cerro Ventana. Cerro and Penchulo. Of these, Cerro Negro is the highest, with a height of 4,409 feet of altitude. So we can see the cones areas down in here. And it's huge. And moving on to the next one, De Mayo. This is Volcán de Mayo. This is a stratovolcano located in the Argentine province of Neuquén, with the height of 402 meters or 15,427 feet. It is the highest mountain in the Patagonia and is sometimes called the roof of Patagonia. The volcano has a large 9-mile wide caldera. At least 14 dacite lava domes are found within the caldera, with another 5 outside. Its slopes contain many fumaroles, hot springs, and geysers. Its name derives from the Mapuche, meaning to tremble and grumble, probably due to the geothermal activity of the volcano. And we're going to look for a view here, because I notice there's a campground over here, and we have one right up on top. How exciting is that? Check out this view. And we're not here to see the people. And there's people that look like geologists, maybe hikers. Thank you for the beautiful view. And moving on to the next one, El Toro Volcanic Field. El Toro Volcanic Field is part of the central volcanic zone of the Andes and the northern Puna of Argentina. 3 of the cones in the volcanic field are located southwest of the town of El Toro, and the 4th is found north. Part of the field of monogenetic volcanoes associated with subduction of the Nazca Plate beneath the South American Plate. It is constructed from 3 main cones and an additional lava flow. The field formed between 6 and 2 million years ago. Wow. And then we can see we have buildings down in here. So let's see if we have a view on this one. No view, you guys. Okay, let's try back up again. And no view. Moving on to the next one. Falso Azufre. Falso Azufre is a complex volcano at the border of Argentina and Chile. Falso Azufre is elongated in the east-west direction and contains craters and lava domes. Most craters have diameters of 980 to 1,970, with the exception of the main crater, which is 0.62 miles by 81 miles wide. This is a huge crater. And I'm curious, so we'll see whether we have a view for this one or not. Would be nice. I saw the blue, but I don't see anything here. Well, maybe over here we go to the lagoon. And the lagoon has a view, so maybe we can look from there at the volcano. We look back over this way, and that's Fossa Azufre. Wow. So it was right here. Awesome. And moving on to the next one. Feraltan Negro. Feraltan Negro is a stratovolcano downgraded by erosion of the Catamarca province of Argentina. It was active between 9 to 8 million years ago. It was formerly a stratovolcano or a multi-vent volcano. Eventually, erosion removed most of the volcano and exposed the underlying structure, including subvolcanic intrusions. The remnants of the volcano are the site of mining operations. Feraltan Negro probably is a stratovolcano which has been degraded by erosion, resulting in the exposure of intrusive bodies. Before the erosion, the volcano may have been 20,000 feet high and covered a surface of 270 square miles. Another theory suggests that Feraltan Negro was a multi-vent complex. The basement altitude is about 8,500 feet wide. These include the Agua Rica and Bajo de la Umbrera porphyry centers and Agua Tapada and Bajo de El Durazno intrusions. Most of the volcanic products of Feraltan Negro are lava flows and breccia. The volcanic vent for most of the Feraltan Negro products appears to be in the general area of Alta de la Blenda, suggesting that it is the location of the vent. So this area is mined. And I notice we have a thing over here. You can see there's a mine over here. I was looking, but we'll go down closer and show you the mine. And this is the Boja de El Umbrera over here. So that's a mine. And moving on to the next one, Galan. This is Cerro Galan. Cerro Galan is a caldera in the Catamarca province of Argentina, one of the largest exposed calderas in the world. It is part of the central volcanic zone of the Andes, one out of several volcanic belts that are found in South America. It is one of several major caldera systems in the central volcanic zone, some of which are grouped into the Altiplano Puna Volcano Complex. Volcanic activity in Galan is an indirect consequence of the subduction of the Nazca Plate beneath the South American plate and involves the penetration of melts into the crust and the formation of secondary magmas, which after storage in the crust gave rise to the dacitic to rhyodacite rocks erupted by the volcano. Galan was active between 5.6 and 4.51 million years ago, when it generated a number of ignimbrites known as the Tuscanquist group, which crop out especially west of the Caldera. 2.8 plus or minus 0.02 million years ago, the largest eruption of the Galan was a source of the Galan ignimbrite, which covered the surroundings of the caldera with ignimbrite material. The volume of this ignimbrite has been estimated to be about 160 cubic square miles. After this eruption, much smaller ignimbrite eruptions took place, and presently 2 hot springs are active in the caldera. Wow. So I'm curious. And we do have some views over here. So there's one hot spring is over in this area. So we'll look at that one in a minute. And we can see this is water here. And the area we're looking at is back in this area. This is Laguna Diamante. We have a view over here. Which isn't much, it doesn't look like too much of water here. There we go. And moving on to the next one. Untitled Volcano group. This is a Stratovolcano Complex. It is a group of young basaltic stratovolcanoes in Argentina near the border with Chile, south of Lenin volcano. The Hanquitihu group is located south of Epulafrunquin Lake, north of Lulug Lake, and west of Rigulil Perihugo Fault. In Chile, volcanism is associated with the Liquine Ofqui Fault. Hanquitihu volcano itself is eroded, but El Escorial cinder cone has been active in the Holocene. One of its tephras overlies an older formation that was erupted 1400 BP. Lavas from this cone form a peninsula in Lake Epuquim and modified the local hydrography. Another cinder cone, La Angostura, formed a peninsula separating the lakes Epulafquin and Huchulafquin. This cone has 3 craters. Okay, so Escorial is there. And we can see the names, and then we have Laguna Verde is over here. Lego Kurahu is here. We're going to back out a little bit and see if we have any views here. And we do have a view here. Awesome. We're going to go right there. Right next to the cinder cone. We're on the cinder cone. Awesome. Okay, guys, this is a cinder cone. So we can't really get a great view of it because we're on it. Let's see if we can go downhill a little bit. We're on a cinder cone, you guys. Cinder cones are not short, so let's go down if we can. Well, I tried to go downward, but that didn't work very good. Try this again. I got an idea. We're going to go right over here. Because this is like really cool looking through here. Oh, awesome. We made it to the bottom, guys. Okay, so we're going to turn around and look this way. And this is a cinder cone here. This is really, really pretty through here. I would like to have a house in the mountains. I think that would be awesome. Okay, and back up we go. And that was the Han Kwiku group. And we're moving on to Nkahasi. And Nkahasi is a volcanic mountain in the Andes of South America. It lies on the border of the Argentine province of Catamarca and the Atacama region of Chile. Nkahasi has a summit elevation of 6,621 meters or 21,722 feet above sea level. The volcano consists of a 2.2-mile wide caldera and 2 stratovolcanoes. 4 pyroclastic cones are located 7 kilometers or 4.3 miles to the northeast and produced basalt andesite lava flows that cover an area of 10 square kilometers or 4 square miles. So we get a good look here. And you can see some of the cinder cones in the area. And we're going to see if we have a view on this one. We have over to the lake. Oh, we have one here. Let's see. Wait, no, we have one here. Let's go right here. I've been lucky with this one. There's been views on this one. Whereas I did a video yesterday and there was barely any views at all. So we can see our volcanoes are over here. We can get our sphere to clear. There we go. We were looking back in here. And that was Nevado, San Friscan, and our area was right behind it. So we're going to look one more time. We're going to go right here, which is right in between the two of them. So when we look again, the one we're looking at, there's this one. The one we're looking at is over in here. Or wait, no, we're looking this way, sorry. Okay, I think we're looking back in here. Yep. Okay, so when we're looking that way, we were looking back in this way, so we weren't able to see over this one. Okay, and we're moving on to Incapilo. Crater Corona del Inca. And this is a Pleistocene caldera, a depression formed by collapse of a volcano in the La Rioja province of Argentina, part of the Argentine Andes. It is considered the southernmost volcanic center in the central volcanic zone of the Andes with Pleistocene activity. Incapilo is one of several ignimbrite or calderic systems that, along with 44 active stratovolcanoes, are part of the central volcanic zone. Subduction of the Nazca Plate beneath the South American plate is responsible for most of the volcanism in the central volcanic zone. After activity in the western Maricunga Belt volcanic arc ceased 6 million years ago, volcanism started up in the Incapilo region, forming the high volcanoes Monte Pasis, Cerro Bonet Chico, and Cerro de Veladero. Later, a number of lava domes formed between these volcanoes. Incapilo is the source of the Incapilo ignimbrite, a medium-sized deposit comparable to the Katmai ignimbrite, with a volume of about 20.4 cubic kilometers or 4.9 cubic miles. The Incapilo ignimbrite was erupted 0.52 plus or minus 0.03 and 0.51 plus or minus 0.04 million years ago. A caldera with dimensions of 5 by 6 kilometers or 3.1 miles by 3.7 miles was formed during the eruption. Later volcanism generated more lava domes within the caldera and a debris flow in the Sierra de Veladero. The lake within the caldera may overlie an area of ongoing hydrothermal activity. Okay, so we're going to see if we can get Okay, sorry, you guys. We're going to see if we can get a view here. Okay. Maybe not on this one. Let's back up a little bit. We can see the Cerro Bonet go over here. And we don't. Oh, we have one view over here. I wonder what this one is. Okay, we'll go right there. No, we didn't. Oops. And we don't have a view on this one, you guys. Sorry. Okay, and wait. Is that one there? Nope. All right. Moving on to the next one, which is Infernillo. Infernillo is a volcanic field in Argentina. The field is located northwest of Malargüe at the Rio Salado. The volcanic field, part of the southern volcanic zone, has formed 3 individual vents with associated lava flows. And let's see. We do have a view in this area, which is awesome. So we'll go right here. We're up in the air here, which is cool. Maybe this is a drone on the side of a mountain. Wow. Okay, so this looks like a drone view. And let's move on and see if we can get another view over here. This is Infernilo, so you can see through here. Let's get it, see if we can have another view. We had one there. We looked at that one, which was down through here. And we're going to come right over here. Which is a road area. Okay, so this is the area we're looking at over here. And moving on to the next one, Laguna Escondida. This is Laguna Escondida there. And this is a caldera in the Andes. The area of the central Andes and the Puna Plateau are covered by thick ignimbrite sheets erupted from large volcanoes, starting from 10 million years ago, probably in the North Puna. In the southern segment of the central Andes, major fault zones are frequently associated with these volcanic centers. The Laguna Escondida caldera has dimensions of 40 by 16 kilometers or 24.9 miles by 9.9 miles and is associated with the Laguna Amarga caldera and the Wheelwright caldera. The caldera formed between 6.5 and 4 million years ago, and the 150 cubic mile wide Laguna Verde ignimbrite is associated with Laguna Escondida and Laguna Amarga. And you can see Laguna Verde is over here, and this is the Escondida over here. So we're going to see if we have any views for this one. Would be nice if we do, but I don't know that we do. And I don't see any yet. So let's back out further. And we don't seem to have one for this one. So moving on to the next one. La Jollada. La Jollada is a volcanic complex in the Andes, directly southwest of Cerro Blanco. The volcanic complex reaches an altitude of approximately 12,500 feet. There's a shopping mall over in here. Haha, that's cool. Okay, so let's do this. We have a view over here. So let's go look over here. Maybe we can look back that way. The area we want to look at is over in here. But this is interesting too. This shows what the areas look like. So La Jollada is here. If there's any more views, we have that one. But there's no more on this one, so we'll be moving on to the next one, which is Lenin. Lenin is an ice-clad, cone-shaped stratovolcano on the border of Argentina and Chile. It forms part of two national parks, Lenin in Argentina and Villarrica in Chile. It is a symbol of the Argentine province of Neuquén, being part of its flag and its anthem. Although the date of its last eruption is not known, it is estimated to have occurred within the last 10,000 years. And I notice there's a street over here. Ooh, we have a view from the top. Let's go to the top of this one. Awesomeness. I don't have anything but an awesome view from here. Whoa, we're on top of the mountain. Oh, well, no, maybe we're not. Uh-oh, campers. Okay, so it's up at the top up here. So we're still at the bottom area, but this is from way up here. Check out this view, you guys. Check out those rocks. Wow. These rocks are huge. Okay, back off. Let's see if we got some more. We'll come further down. We'll come down here. Check out that view. I can only imagine these people must be having fun camping out here, because that would be an awesome time. Is that gorgeous or what? Okay, guys, moving on to the next one, which is Listaria. Volcan Listaria. Volcan Listaria is a volcano that lies on the border between Chile and Argentina. It is part of the Central Volcanic Zone, one of the four segments of the volcanic arch of the Andes. Several volcanoes are located in this chain of volcanoes, which is formed by subduction of the Nazca Plate beneath the South American Plate. Listaria is formed by two volcanic edifices and one subsidiary lava flow field. There is no recorded eruptive activity, but the volcano displays vigorous fumarolic activity. It is located on top of the older volcanic rocks and features both andesite and dacite. Listaria has produced a large landslide deposit as well as flows of molten sulfur. A progressive uplift of the terrain around Listaria and further south has been recognized. And that's Listaria there. We're going to check for views here. And we have no views. Okay, you guys, stay tuned for part 2, and we'll be back in a few minutes.